Hi there, I'm Alex McDermott, and if you're familiar with Submer, I'm with a man that needs no introduction, Daniel Pope, our CTO and founder. And today we're going to be tackling the barriers to adoption for immersion cooling. But first of all, Danny, I'd like to know how you see the immersion cooling landscape at the moment.
Hi, Alex. Thank you, and hi, everyone. I would say that currently in the immersion cooling space, what's happening is a lot of the standards are being defined in the industry. So we see a lot of things happening in the OCP communities, in the ASHRAE community, defining all the standards that the industry needs for mass adoption of the technology. I would say that we also have the server manufacturers kind of coming on board with the technology and releasing more and more solutions and products that are ready for immersion. And we also have the silicon manufacturers that are planning immersion in their roadmaps. Intel has been very public about it, all the way to the foundries as well in some of their keynotes. And so basically, the supply chain and the ecosystem for the industry is getting ready for scale. We're also seeing bigger deployments, so megawatt deployments with different customers, and we're also gaining a lot of expertise and feedback from long-term deployments that we have in the field with reliability and performance data that is very promising as well.
So if I was someone just starting out on my immersion cooling journey, what's typically the first obstacle I would face?
Yeah, I would say you've now got like this wide array of solutions that are on the market, right? So there are different technologies when it comes to high density computing and cooling that you can use. And then the question is, which one makes most sense, right? And I think that's one of the biggest challenges for anyone that is now trying to figure out how to deploy immersion cooling, high density compute. And so the question there becomes, okay, what technology should I use? We believe it all boils down to TCO, and that immersion cooling can defend the most competitive TCO. When you look at the full infrastructure, like from the chip, what happens at the rack level, what happens at the server level, at the rack level, at the data hall level, at the cooling infrastructure level, and you have all these compounded benefits that just bring this unprecedented TCO. So I'd say that's probably the biggest challenge right now, one of the barriers of adoption.
There also seems to be this perception that immersion is a bit messy and you need specialized personnel. How would you answer that one?
Yeah, so we're quite used to training IT operations personnel in immersion, but I think people need to be aware that really you just have much lower failure rates in immersion. So you're looking at usually less than 1% per year, which really limits the amount of operations that you're going to be doing with a system, right? So we're looking at different things. One is fewer operations, and then how do we optimize the very few operations that are left, right? And so our products and the way we integrate systems, server systems into our products, we're really looking at minimizing the challenges for day-to-day operations through tools, standard operating procedures, and obviously being able to easily train personnel to do that, which is honestly just a matter of minutes or very few hours to ramp someone up from standard rack operations to immersion operations.
And I understand that sustainability regulations are also tightening just now. What are the main ones being faced by data centers at the moment?
Yeah, so at a European level, for sure, you have a few. I would say one is around the two-phase fluids that you can use in a data center. And this doesn't only apply to potential two-phase immersion fluids, which as well, but also to the two-phase fluids that are implemented in the cooling towers. So there's a whole regulation to ban a lot of these two-phase fluids because of the environmental impact that they have and risk for people and the planet. The other one is around water, so water scarcity and reducing or improving the water usage effectiveness in data centers. There is a strong regulation in Europe around that, and there are actually quite a few hyperscalers that are being heavily challenged publicly about access to water. Their site selection process is becoming more complex because of that. And we've seen a lot of news also in quite a few of the US states where maybe drier states, where they're like Arizona and others, where hyperscalers are also challenged by water scarcity. And then the other one would be, I would say, probably the efficiency in itself of the data center infrastructure, right? And that ties into the potential for reuse of energy from that data center, so heat reuse. In Europe already, some countries have already implemented the requirement for future data centers to capture and reuse a specific percentage of the heat, like in Germany. 10% or 20% heat capture is mandatory. We're going to see that across more countries in the future. So what technology can solve all those very efficiently? Obviously, we're positioned in Immersion as the one that's most capable of removing all these challenges when it comes to regulations.
Can you go into more detail into how Immersion answers these challenges, such as the water one, for example?
Yeah, so Immersion allows us to run high-density compute systems with very warm water. So that basically translates into not having to produce cold water. And by not having to produce cold water, we can use a technology that is called dry cooling, which are basically giant radiators that sit outside of the data center. Our systems today are able to operate with 32C and even 40C water supply in some scenarios, which means you can run this cooling infrastructure, this dry cooling infrastructure all year round in a lot of locations on the planet. And then the customers, instead of using evaporative cooling technologies like they've been doing up until now, because of the energy savings that Immersion brings, they say, okay, I'm not going to deploy an evaporative cooling tower, I'm just going to have some chiller-based peak shaving. So if I ever do reach a day or hours of the day where I can't produce 32 or 40C water in a dry cooled environment, I'll use a little tiny bit of chilling, which means a little bit more energy, but it's still zero water consumption and evaporation.
And what can immersion cooling offer in terms of heat reuse?
Yeah, so connecting it, I guess, with that water supply, we're able to supply 32 or 40C water to a system. The return is obviously incremented by the heat of the compute, and it can be substantially incremented. So today we're able to typically recover 60C, and we've done experiments, and we have papers published where we're achieving more than 70C. So by designing the hardware in an optimized way for immersion, we can match 4th and 5th generation district heating network requirements with the direct output of the immersion systems. And there's no other technology that can achieve that. And it's just kind of that warm water is just the byproduct of our system, I guess.
So with all this in mind, all these obstacles and solutions we've discussed, how do you see the immersion cooling landscape evolving in the next few years?
Yeah, good question. So I would say that what we're going to see is an accelerated adoption, and it's obvious with what you see in the market and on the press, of the technologies that are less of a mental leap to overcome, I guess. So we'll see a lot of obviously direct to the chip cooling being rolled out. But we do anticipate, and there's a lot of market research already published about this, that the percentage of immersion cooling is going to increment year over year versus the percentage of direct to the chip. And the reason for that is primarily the fact that customers are going to realize the challenges that come with direct to the chip. They're going to spend time analyzing the total cost of ownership and the return of investment. And then in the refresh of those systems, we're pretty sure that they will revisit a different technology if they haven't chosen immersion on that first step of the journey, right? So what I envision in 5 years from now is that we will see more immersion than direct to the chip because more customers will have already gone on that journey. And I invite everyone who is watching this video to actually spend the time, as I mentioned, to analyze what happens during the heat path from the chip to the secondary cooling infrastructure and the impact that it has on the facility, on the systems, on the energy and water consumption, etc., when they're putting their TCOs together.
Well, I think that concludes our conversation for today. Thank you for your time, Danny. And if you'd like to know more about immersion cooling, or you need some more support on your immersion cooling journey, please don't hesitate to get in touch and keep up with us on our social media channels. Thank you.
Submer, data centers that make sense.